Hi Kickstarter, I'm Connor.
And I'm Joel, and we're bringing you OpenBCI, an open source, low-cost EEG system for makers.
We want to lower the barrier of entry for brain-computer interfacing enthusiasts.
When you support OpenBCI, you get a Bluetooth-enabled EEG system for makers. It's going to have an Arduino on board, and it's fully programmable. But it's not just about EEG. Your body outputs all kinds of electrical potentials that we can measure with OpenBCI. So we're also going to be providing a biopotential suite for sensing ECG and EMG. That's heartbeat and muscle movements.
There's a lot of EEG platforms out there, but most of them are closed in some way or another. Either they do not allow you to put the electrodes where you want them to be, or the data is not accessible, and so it makes it very hard to do what you really want to do with the system.
To get started, you need a computer,
an OpenBCI board,
some cables and electrodes,
and a brain. First, download the OpenBCI code examples and libraries from our GitHub.
Second, upload the Arduino code just like you would any other sketch.
Third, launch the OpenBCI Brainwave Visualizer. It has been ported to a number of open source software platforms.
Fourth, apply the electrodes to your head and connect your brain to your computer with OpenBCI.
Then, see your brainwaves in real time.
So here we have the OpenBCI Brainwave Visualizer. It's connected to Connor's head. And right now you can see some eye blinks going by in the time domain spectrum here on the right. And we have an FFT plot on the left. A map of the electrodes, you can see the numbers corresponding to the waves here on the right. The two in the front are receiving most of the eye blink artifact. Connor, grit your teeth a little bit. You can see that the EMG artifact is showing up here across almost all the channels. So a good way of doing a test here with the EEG signal, making sure we got all the connections we need, is if Connor closes his eyes, which he's doing now, we should see a high frequency or high amplitude alpha wave, which is in the 10 Hertz band, which is what we're seeing down here in the FFT plot.
I think what makes OpenBCI different than what's currently available is that you have full access to the data, full access to the algorithms, full access to the configuration of the hardware. And this opens up so many possibilities to explore what can be done in the brain-computer interface field.
We see a variety of different people being interested in this, coming from different backgrounds. So, typically EEG and brain-computer interfaces, or at least historically, they were set in research and academic settings, but now there's this movement to bring the technology out of the academic setting, out of the research setting, and give it to just an everyday person. And so we see artists, creators, computer scientists just using this as more of a hobby thing than actually a research grade EEG, even though it's just as powerful.
I'm a neuroscientist, and I've been trained that way for the past 10 years. As such, my thinking about neuroscientific questions is, in a way, bounded. And the more people that you can bring to the table who are interested in the same questions, but who have different expertise, different training, different knowledge base, the more creative, new, innovative ideas you're going to be able to come up with.
We've been prototyping the hardware all summer long, and we really feel like it's at a point now when we can really start to share it. We're here at ThoughtWorks today with our first hackathon, bringing people together, software programmers, hardware engineers, people with general interest, to share ideas and help push OpenBCI forward to make it accessible for everybody.
As we're walking around, we're constantly labeling the world around us as interesting or uninteresting, things that you care about or you don't. And there's a signal associated with that we recognize in the laboratory, but we don't know what it looks like in the real world, where you're walking around, where you're moving your eyes freely. And something like OpenBCI gives you a chance to see what those signals look like in the world where you really want to use them.
Currently, brain-computer interfaces, they have a lot of amazing implications. It's just that not enough people are using them. And so our mission is to not only sell a product, but teach people how to use this product and host hackathons and meetups and share knowledge about brain-computer interfacing.
So thanks, Kickstarter. We really hope that you support our project.
Why choose one decor when you can turn your wall into an interactive canvas? Meet Scribit, the world's first write and erase robot that creates a different image whenever you want. 2 nails and a plug is all you need to install Scribit. And thanks to the app, it's always connected. Create an image or source it from the web, then upload it to the app and Scribit will reproduce it on your wall within minutes. And if you get tired of the design, no worries. Scribit will just erase it and you can start over again. You can connect Scribit to your favorite apps and show you the latest news and weather forecast, or even your Twitter updates. Any surface is game. Whiteboard, glass, or standard plaster. And with 4 color options, the possibilities are endless. The only limit is your imagination. Turn your wall into a wonder wall with Scribit.
Today we need information, but we spend too much time in front of screens, from our smartphones, computers, TVs. So the question is, how can we get information and data, but without adding more screens to our lives?
What I love about Scribit is that it can literally turn every surface you have around you into something dynamic. Surfaces that can show data, art, or murals that remind you of the good times. And it's an amazing way not just to help you work, live, but also to interact with other people and to interact remotely as well with other people of your life.
Really, what you can do is limitless. Think about having a super gifted hand. It's a robotic hand and doing whatever you want on the wall. You can think about basic information as, the weather forecast or the things you need to buy. It's like having an infinite library of apps that allow you to turn anything you like into something on your wall.
What I like the most about Scribit is that it enhances everyone's creativity and lets you transform your house in a more beautiful place to live. Scribit hangs on the wall with just 2 tiny wires, and it moves thanks to its 2 motors. Also, we identified a new ink which is completely erasable with heat. A fundamental part of Scribit's user experience is the platform that allows people to upload, share, and download contents to display on their walls.
The whole concept behind Scribit is to create a community, and everyone is already excited about it. I can't wait to see what artists and people will do with the platform. Imagine drawing and sharing with Scribit. The possibilities are endless.
Crowdfunding is amazing because it's a way for us to understand what you think about our idea and for you to get your Scribit before than anyone else. So please support us in any way you can, because this will help us to bring Scribit into your hands as soon as possible.
When the first SnapMaker was introduced, it raised over $2 million. and connected over 10,000 users in an active community. With the new SnapMaker, we're bringing the next generation of advanced technology to this iconic design. The new SnapMaker is faster, smarter, larger, and more powerful than ever before. From 3D printing to laser engraving and cutting and CNC carving, it supports a wide variety of materials for limitless creativity. The components are made from high-strength metal. Anodizing converts the surface of the metal into a durable anodic oxide finish. Each process is strictly controlled. And due to the higher level of automation, both the quality and the speed of production have been significantly increased. Every part is meticulously made. In creating the new SnapMaker, we've taken the all-metal design to the next level. The new SnapMaker is modular, and it only takes a few steps to set up. Our software has greatly simplified the process of 3D printing, laser engraving, and CNC carving. You can also connect and control your SnapMaker via Wi-Fi or with the smart touchscreen. SnapMaker is more than just a series of machines. It's a system of powerful modules and add-ons for creative people like you. You can make an extra-large CNC router, a huge laser engraver, and even a 4-axis CNC machine. You can further enhance it by adding an IP camera, a hand wheel, an emergency stop button, an enclosure, and more. The new SnapMaker includes an automatic bed leveling feature that ensures you print on a level bed every time. The cooling system is redesigned to cool the print in the most efficient way possible. If the filament runs out, SnapMaker will pause and notify you to load new filament. It can also detect power loss and resumes exactly where it left off, so you can recover any project. To remove a print, simply lift the build plate and flex it. For laser cutting, it uses a specially designed aluminum grid table. Its built-in camera allows you to preview a design on any material or surface. What you see is what you get. It makes laser cutting as easy as drawing with a pen. It can convert your drawing into a vector image that can be edited directly in the software for laser engraving and cutting. It is 5 times faster than the original model. Whenever a new idea strikes, you'll be ready to turn it into reality. For CNC carving, it now features a fully upgraded CNC module and wasteboard. It supports over 100 carving and cutting bits by using the standard ER11 collet. Upgraded clamps provide a tighter hold. It has faster working speed, a larger step down, and fully enclosed linear modules. Bring your ideas to life and unlock your full creative potential with the new SnapMaker. It is the most advanced 3-in-1 3D printer we've ever created. Let's make something wonderful with SnapMaker. Join us and back us on Kickstarter today.
My name is Josh Vector.
And this is the WOE board. It makes things glow. It also makes glowy things touch sensitive. People make lots of different electroluminescent or EL glowy things.
People make panels of this stuff. Some of these panels are even cuttable, so you can make crazy shapes that you can cut out and the whole thing will glow. People make tape. People make wire that's easier to sew. People make these kind of crazy synthesizer things that can respond to music. People even take the wire and put it around things like glasses. People also make EL paint. The WOE board is an open source prototyping platform for wearable electronics that has a quiet EL driver built in. So all you need to get started is a piece of EL and a battery. There's no programming required. It also speaks the Arduino programming language, so you can make it do whatever you want. You can make it talk to a computer or output MIDI. You can make it talk wirelessly to other boards. You can even make it listen to a banana. The whole point is to make it easy to play and discover new applications for interactive and wearable life. To do this, it turns EL materials into touch sensors, specifically capacitive sensors, like a cell phone screen.
This sensing works through thick fabrics, like felt. It also works at a distance, so you can make the visual theremin you've always wanted. We have used this capability to make everything from a bike jacket, whose integrated turn signals can be triggered with the shrug of a shoulder, to leggings, whose light dances with your movement. Everyone we talk to seems to have their own design ideas.
I'd be excited to do anything from performance, which means athletic wear, things that people wear at night, things like motorcycles, bicycles, runners at night. All of these people need to have things to wear that will be safe and functional. Also things like dance are really exciting.
I've never heard of using the EL itself as the trigger. That's really cool.
It is.
Like something like this, like some sort of paneling, some sort of performance where they're like touching the panels or something. For us, it's like all performance and dancers and stuff. So it's like, you know, there'd be like probably a couple of dancers carrying out this panel, and then a dancer goes and does some stuff with it.
This all started as an art project. I started working with electroluminescent materials a year ago, and I wanted to figure out how to make them touch sensitive. But it turned out that no one had done that before. So I asked my dad for help, because he's a great electrical engineer. And together we made our first prototype. And it worked, which got us to keep working. And so since then we've been refining our design and making it smaller and more usable and more sensitive. The wallboard enables interactions that are unlike anything else, and we've had a great time playing with it for the past year. But now we want to see what you can do with it. And that's why we're coming to Kickstarter, to rally a creative community that's interested in exploring this new frontier of wearable technology. We hope that you'll join us.